Welcome, everyone. We'll be starting in about 1 minute. All right. Hello, everyone, and welcome to today's SANS webcast, Where We Are Going, We Don't Need Roads, with Eric Johnson. My name is Laura Dawson, and I'll be moderating today's webcast. Eric is a co-founder and principal security engineer at Puma Security and a senior instructor with the SANS Institute. His experience includes cloud security assessments, cloud infrastructure automation, static source code analysis, web and mobile application pen testing, secure development, lifecycle consulting, and secure code review assessments. Eric is the lead author and an instructor for SEC 540, Cloud Security and DevSecOps Automation, and a co-author and instructor for SEC 510, Public Cloud Security, AWS, Azure, and GCP. Additionally, Eric is a SANS Security Awareness Developer Training Advisory Board member and SANS Analyst for Application Security and DevSecOps surveys. If you have any questions for Eric during the webcast, please enter them into the question window at any time. Please note that our webcast is being recorded and will be available for viewing later on the SANS webcast registration page, as well as in your SANS account under My Webcasts. And with that, I'll turn it over to you, Eric.
All right. Thank you, Laura. Welcome, everyone. Good morning, afternoon, or evening, depending on where you are out there in the world. Very honored to be back on the SANS webcast circuit speaking with you today. The title of this webcast, obviously a play on one of my favorite series, Back to the Future, is going to be focused on IT operations and the fast-paced journey kind of into the future of IT that organizations are taking to accelerate their software delivery and also accelerate and update their security and their governance programs. Laura did an amazing job with my intro, so I won't dwell on much of what's on this slide, but this is myself in a snapshot. I've had the benefit in my career of transitioning from the first 3 to 4 years of my journey as a developer, where we wrote code, and it was for a big financial institution that ended up as part of financial and kind of bankruptcy or workflow systems used to process financial transactions, then transitioning into more of an application security role and then an operational role after that. And now I really, from a job title perspective, as I do work with my company, Puma Security, just call myself a security engineer. And that could encompass really security and development, operations, or doing audits and risk assessments and things like that. The majority of the lessons learned from that, it's coming up on almost a 20-year career for myself, have really played a part in building and curating the SEC 540 course, which is Cloud Security and DevSecOps Automation. Myself, Ben Allen, and Frank Kim are the primary authors on that course, and this particular discussion today is geared towards teaching you a little bit about what we cover in that course, and also some of the reasons behind why organizations are transitioning into this more DevSecOps model for delivering features faster to their customers. My contact info is on the slide. You can find me at emjohn20 on Twitter. My LinkedIn URL is there, and you can also just shoot me an email if you've got questions or follow-up ideas for maybe other things we could be covering on future webcasts, or even ways to get involved with SANS in the cloud security curriculum. Don't hesitate to reach out. We always look forward to getting more folks involved in these sorts of discussions. As you take a look at our agenda for today, we've got 3 key sections that we're going to walk through. And the first section is more geared towards the reasons why we are going to talk about sections 2 and 3. So I've titled it Gates to Guardrails. And this was an approach popularized by Netflix. It's been several years as they've kind of gone through their journey to becoming one of the most popular streaming services out there. And we're going to take a deeper look at the State of DevOps report. And that report, which is published by DORA, the DevOps Research and Assessment Team, talks about acceleration and performance and security metrics for some of the high, medium, and maybe low performing DevOps organizations that took that survey. What we'll find out is that as you mature in DevOps in general, governance actually is more likely to be a part of that program. And then we'll spend some time taking a look at what those security controls look like and how they're being transitioned into a continuous security or a continuous feedback model as you shift left all the way to the development side of the workflow, and then as well as shifting right to the operational side of the workflow. As we take our first peek at Gates to Guardrails, let's start kind of at the beginning of this conversation. What did things actually look like, once upon a time in a traditional enterprise, maybe in financials, or maybe in healthcare, or maybe even in a Department of Defense, a more regulated industry? My very early on journey, as I was the developer side of this conversation here, the very first time I stepped into an office, as a 20-something-year-old, I thought to myself, all right, I'm going to start writing some code today. And very quickly, in a more waterfall-driven methodology, I found out that there were a lot of things that had to be done before we could actually write code and make changes. We had requirements documents, design documents. We had to go through the actual coding process, and then we kind of checked that in to a version control system, and it would sit there for weeks under a quote code freeze before anything was actually allowed to change. And the reason for that was our first wall of confusion on this slide was the operational team, and their aspirations were stability. Change meant downtime, and downtime affects their metrics and their performance numbers. So there was friction there. And if you thought the operational team added friction, then we've got another wall, which is the traditional security team. And the security team, they want patches, but they also want perfection in a lot of ideals in that waterfall mentality. We want to be able to have gates on the deployment process where I can do very slow, maybe manual code reviews, or maybe check all the compliance boxes and make sure that all of the firewall rules are good, make sure we're not exposing endpoints with vulnerabilities that could be found by dynamic analysis tools like Zap or like Burp Suite or something like that. And we had to wait for all of that perfection to be done just to get that little change out the door. What ultimately ended up happening with this is that we ended up with some competing interests here. The development team is measured based on feature delivery, and the operational team is directly competing against that. They want stability and they want uptime. The security team is measured by, well, how many vulnerabilities are found out in production. So you've got all of these different teams with different goals that are not working together. And the end result is slow-moving projects that are over budget, that are months and months behind, and the end result is our customer likely being unhappy with the feature set or the status of their ticket in this particular system that we're talking about. So as you look at the transition over the years, as we've gone from that waterfall style into more of a performance-driven workflow, you're starting to see, whether it was 5, 10 years ago, or even right now, organizations are starting to focus relentlessly on improving their delivery performance. And if you take a peek at the most recent state of the DevOps report, so this is from the 2021 report, we've got some interesting metrics here that talk about how performers are actually measuring frequency. How often are we delivering features to our customer? If you look in that elite category, so these are folks like at Netflix or Etsy or Amazon, they're used to delivering features multiple times a day. So that's the deployment frequency. If I need to make a change to a production environment, pretend it's a security patch to some system, I can deploy that the day that I find out about the problem. I might give your operational or security team a 1 hour notice. Hey, that's your code freeze right there, if you want to even call it that. You're getting an hour's notice that this is going to ship through some sort of automated pipeline. If something happens to fail, the time to recover from that failure is going to be less than an hour. And the failure rate, if you compare that across the board, is less than 15% of production changes are actually resulting in some sort of an incident or some sort of downtime. So it's interesting if you look through that, the more often we deploy, the faster we can go, but also the more safe our deployments are. And it kind of makes sense if you think about it, because we're practicing our deployments every single day. We're getting really, really good at it before where maybe we're going a little bit slower. If you look on the low end of this slide, where we've got only a deployment frequency of every 6 months, and that change failure rate creeps up to about 30%, because you've got changes that are sitting there undeployed, kind of aging out. I almost view those as technical debt, because the longer that change sits there, the more the environment that it needs to go in changes around it, which can cause problems. So you're seeing a huge emphasis on speed in this report. If you look at the acceleration trends comparing 2018 to 2019 to 2021, there's also some interesting changes in the numbers there as well. So if you look at the number of low performers, those that are deploying, less than once every 6 months. If you look at 2018, we had 15% of the respondents were in that slower moving bucket. You've seen that cut in half over the 4-year span there. As we head into 2022, we've got only 7% now are in that low performing bucket. And I suspect that number will continue to get smaller and smaller, because people are realizing we need to move faster in order to keep up with our competitors. If you look at the high and elites, we've got a total now of over 60% of the responders deploying at least on that weekly and all the way into maybe that daily basis. So for the first time, we've got the elite performers also making up over 25% of the respondents as well, which those are daily deployments. So you're seeing everyone kind of moving up, setting that target goal to be, let's be able to, if we need to, patch something within a week and maybe even the day of. Very heavy emphasis on moving faster. The question that I always circle back to is, what were the underlying reasons why we went from that waterfall driven, maybe deploying something every 6 months, to something like, let's go weekly or daily? What are the reasons that we're actually doing this? Now, I've mentioned this in passing, but let's explicitly call it out. The slower we go, the less features are being delivered to our customers. And our customers in that moment, if you're being slow and or not delivering things that they need, you're going to risk losing market share, because there's some other company that's moving faster into the future, for our title reference, and they are going to start picking up the customers that are just looking for the new, more modern features available, whether it's in the mobile app or the web app or whatever this thing is doing. Some of the byproducts of moving slower are also failed deployments and downtime and not being ready to actually restore a service quickly. If I think back to some of the systems that went down, potentially maybe during deployments in my early on development days, when we broke some sort of a system. Now we did Tuesday night deployments, and we would kind of laugh, and then it's because we were up all night on Tuesday nights. So Wednesdays were a pretty unproductive day for everyone, if you even ended up coming into work at all, because you might have been up all night trying to get something back online by 7 or 8 a.m. when the US businesses came online. That is an issue. If you're down for 8 hours when something breaks, you are going to incur some reputational damage. And again, you might be losing customers. So as you take a look at some of the other metrics, comparing the elite to the low performers in the report, it becomes pretty clear why folks are doing this. Obviously, delivering features, you're delivering 973 more features than a low performer. You are 3 times less likely to fail during a deployment, which means your uptime is actually going to be better by changing things more often. And then you look at the mean time to recover, the MTTR metric, and we're recovering, instead of 8 hours, we're dividing that by 6,570. That's how much faster we can actually recover from incidents. So these are all metrics that are very interesting inside of that State of DevOps report. I would highly encourage you to go check that out. Go read through that report, and it'll give you a pretty good idea of the reasons why we're seeing DevOps and even DevSecOps, or this modern IT engineering practice, kind of take off throughout the world. Many of you might be thinking, well, I thought this was a security discussion, not a DevOps discussion. As you look into the report a little bit, you will see some metrics about security practices on the teams that are elite and or high performing. And this is where you get the security part, the sec in the DevSecOps conversation. Now, if you look at the elite performers, and this goes way back, one of the very first SANS events that I ever attended was back in 2012. It was an application security summit that was in Las Vegas in the Paris Hotel. I still remember walking in there and listening to speakers from a number of different companies like Etsy and Netflix, and even some financial kind of technology-driven companies talk about how their security program was evolving to keep up with the pace that the development teams were actually using. And it kind of blew my mind. Coming out of a more traditional financial enterprise level mentality, my first impression was there's no way that security is keeping up with deploying code 50 times a day. And over this 2-day summit, it almost shifted my mindset a little bit. That was kind of that eye-opening moment for me, where I realized that this is the way the world is headed. We're heading into automation-driven security. The cloud is going to explode inside of every sector. It doesn't matter which sector you are. And we probably need to figure out how to start leveraging security controls, even capabilities in the cloud, to do things a little bit faster. I went to management on our security leadership team, shortly after that summit, and said, this is what's happening at all of these smaller kind of fintechs and things like that, and walked through some of the different methodologies for achieving our traditional security controls. And the response was at that time, well, that's probably not going to take off. Could you imagine a regulated financial industry kind of enterprise doing DevOps and going into the cloud? And we almost laughed about it, right? That would never happen. Looking back in hindsight, 10 years later, you've seen this take off. Capital One was kind of the first major financial that said, yeah, we're going to start learning how to turn our battleship on a dime. We're going cloud first. And in order to do that, our security teams needed to learn how to almost reinvent governance. So when you talk about a lot of the governance policies and the way that things used to be, what we've really done is learned how to reinvent them and integrate them into different phases of what we call the DevSecOps workflow or the development lifecycle. If you take a look at the numbers on this slide, you'll see that security practices are just being integrated throughout the entire ecosystem on these elite performers. They're still doing the same actions. It's just continuous. It's not a gate or a checkbox on a compliance document. So for the rest of the discussion, we'll take a look at some of these controls, and I'll show you a number of different concepts and tools that can be achieved to perform this continuous security approach. As we look at shifting left, what does that really mean? It's kind of that term that everybody likes to talk about, but what's actually involved in this? How do you do it? What you're going to end up needing are developer-oriented mindsets to be working with security folks that have some checks and balances that need to happen a little bit early on in the workflow. So the next several slides will walk you through the pre-commit and commit phases of what I like to call, the DevSecOps critical security controls. And it goes through from starting on the Monday morning sprint as you're looking at your project board or your Kanban board with all of the things that we need to do, is you move a ticket from waiting to in progress, doing some basic threat modeling and talking about the security implications of this particular change early on can do a lot for security up front. And sometimes you will see those discussions turn into, maybe I need to get someone from the security team more involved with this project. And that particular security engineer can work with the dev team for that week or maybe 2 weeks while this particular feature is implemented. And that establishes some rapport, kind of knocking over that very early silo that I showed you at the beginning of the presentation. We'll look at some IDE security plugins and how version control systems can help you enforce security requirements throughout. We'll then take a look at the commit phase, which is when we perform that merge request. When I hit that merge button and we make a commit to an actual develop or a main branch that's going to send something out the door into an environment, what security checks can be automated or added in that particular phase? And then we follow it down the line as we shift further right in our workflow, as we spin up maybe a Phoenix server for running some actual tests against them. What infrastructure as code automation is required, what dynamic security tests or maybe custom acceptance tests need to be there to help certify that the workload is ready to move into production, where we can monitor it as well as run some operational techniques continuously in production to complete the feedback loop for the next sprint. That's the workflow, folks. We have flattened out all of our controls across the entire workflow rather than stacking them all up and putting a gate right there at the production phase and waiting for them to be completed. As we look at paving the development path, right, moving from gates to guardrails, one of the first things that we should really be taking a look at is how to share reusable, secure by default templates. And this could be really for any application. This could be for an API, maybe written in Node.js or maybe in a .NET Core-ish style framework that's running inside of a container. So you can build those secure by default templates that have custom code already in them for performing secrets management correctly, reading values from a cloud KMS service at runtime rather than from a config file or some hard-coded file on the file system. You can pre-configure HTTPS or headers, maybe that set up content security policy or require, the HSTS header for secure transport. You can set all of that up ahead of time. Authentication and authorization might be baked into the system. You've got configuration with your identity provider already in there. We're pulling in package references for data validation, talking to database services, automatically setting up audit logging and things like that that need to be there. Envision this template where there's a little method that says, here's a get, put, post, patch, and delete API method with a comment in there that says, Eric, write your code here and don't touch anything else. Those secure by default templates can provide a tremendous lift for security teams, as well as prevent a number of assumptions or misconfigurations that might be introduced by an engineer just building one of these from scratch. So think of that reusable module approach and then apply that to your entire infrastructure, from your cloud infrastructure in Terraform to your golden images being built, maybe with Ansible, all the way up to the API that's going to run on top of that server. Use that approach for every aspect of this entire end-to-end workflow. Regardless of what the actual code is going to be in, your next step is really getting into the code editor, which we thank Microsoft for building and open sourcing VS Code. That ultimately has kind of become the go-to de facto editor now for most development teams. And the best part about this is there's a massive ecosystem for security tooling that can be installed inside of the actual editor. So rather than waiting for the security team to go run some code analysis tool or run some policies against some of the configuration files, you can install extensions that run them locally in the editor to get some very early feedback. Now, as we know, some of these tools are more analyst tools and they might take a really long time to run. Those are not good candidates for this particular point. But you can run very lightweight static analysis tools such as SimGrep or the PumaScan extension, and you can get very nice IntelliSense in the code editor that says, hey, Eric, you just kind of wrote this API method. That API method has a path traversal issue in it. It could result in access to maybe the cloud metadata service. That's probably something that you would want to fix before you actually commit that to version control. If you're writing code like Terraform or Kubernetes manifests or Docker files, something like Checkoff can do some configuration file analysis for you and say, oh, hey, Eric, you're about to run that container as privileged. You probably don't want to do that on your Kubernetes cluster. Or your Kubernetes cluster is missing maybe a network policy, and all of these containers are kind of talking to each other unrestricted inside of the cluster. Checkoff can give you that configuration file analysis to alert you to those sorts of issues. The open policy agent, that is completely customized policy you can write to enforce requirements. And you can install the open policy agent plugin and start enforcing customizations to your configuration management files right there in VS Code before you commit anything to version control. That's as far left as you can shift, folks. Right as you're writing something, VS Code is evaluating that configuration or that source code, and it's telling you, oh, you may have made a mistake. You might want to take a look at that again. The next step of the conversation is really looking at how to auto run or maybe even enforce some of those scanners. So as you take a look at how you can run these things, we leverage a lot of pre-commit hooks that are driven by the pre-commit framework. And what this does is you can configure a YAML file. I'm showing you just a very basic YAML file that can run some custom scripts or any of the tools I mentioned on the previous slide for you when you run a git commit action locally on the development workstation. Now, this particular configuration is going to install and run ESLint, which is a little JavaScript linter, but it's also installing a tool called Get Secrets from some of the pre-commit hooks available inside of the pre-commit GitHub repo. So based on this YAML file, all you've got to do when you clone a repo is run a pre-commit install, and it will go in on your local machine. It will install these particular tools and set up the pre-commit hook to actually run them automatically for you. So in case I miss a warning inside of VS Code, now I've got another check here that's going to validate the pre-commit hooks that we've got set up, and it'll tell me if something failed before I accidentally commit that change and maybe push it up to our version control system. So we've got two checks happening locally, again, as far left as we can shift before we move into the version control phase. Now, version control security is a loaded topic, and we could spend an hour just talking about all of the different topics on this slide. My intention is to give you some things to go look at after you listen to this discussion. Whatever version control system you're using, you need to go find the equivalent features that allow you to enforce some compliance requirements. Those would include, number one, branch protections. Is you're merging changes. So think of a developer, maybe I'm writing a feature slash, here's a new API, some new endpoint that I'm going to throw out into the system. And then when I'm ready to push that out to a dev environment, I would open up what's called a merge or a pull request to merge my feature branch into the develop branch. If that's going to a live running environment, we need to enforce peer reviews in that moment. Similarly, merging develop into the main branch, we would also want to enforce peer reviews for that particular action. Branch protections allow you to do that. It says if I change something, some other developer or some other subject matter expert is going to have to review my changes and approve them to go into that environment. That's a massive security control to help achieve separation of duties and also enforce change approval that can be done by version control. A very unique characteristic inside of that process is also the ability to define what you would call code owners. Now, code owners require maybe some customizations to the who can actually approve those pull requests from the previous step. So if I go in and I change maybe a Kubernetes manifest or the Docker file, you can set up code owners on those files that says somebody on the cloud infrastructure team also needs to approve this change because I changed something that might impact the cloud infrastructure. And you can go up and set up an inventory inside of every repo, identify that high-risk code that might need the additional subject matter expert reviews before we're actually allowed to move forward. Another cool feature in version control are pull request templates. Now, what we use these for, they're little markdown files you can put in hidden directories kind of inside of the Git repo. And what you can do is actually pre-populate. When I open up a merge request, you can pre-populate those merge request descriptions with a template. Now, the cool thing is inside of that template, you can put things like, did you perform or fill out the rapid risk assessment questionnaire for this particular update? Make sure the security team doesn't need to be more involved. Did you run the unit tests, which might include a number of different security focused, maybe evil user stories or abuse cases that would be burned into unit tests? We're going to revalidate some of our security checks in that moment. Did you go in and maybe validate or rerun semgrep, for example, against your Python code to make sure that that comes up clean and there's no new static analysis rules that need to be evaluated or maybe even suppressed if they're false positives? the merge request templates are really good at just kind of a visual reminder for all of the development folks that, oh yeah, I need to do these particular things in order before I open this up. And then your merge request reviewers can go in and make sure they're all done, right? Trust but verify before we actually approve that request. Another piece to this is using a GitHub app if you're in the GitHub ecosystem called All-Star. So All-Star continuously monitors your organizational repos against a policy that you put together. And it'll come in and say, hey, is there potentially you've got a policy that says you have to have branch protections and you have to have a code owner's file. For example, All-Star will tell you if you have correctly configured all of these things. So that's a cool app that can help you enforce version control configurations and evaluate them against some custom policy that you've put together. Put that all together and you've locked your version control system down to the point where we should have a very smooth CI/CD driven workflow to actually deploying the workload. And engineers can't just deploy things at a whim, right? It has to go through those security checks. Now, there are a number of different CI/CD concepts and tools out there that can help you deploy things out into dev or prod or whatever the environment is. The goal for these workflows is to revalidate and actually generate audit reports or audit evidence for everything I just described to you that should have happened up to the point of approving that merge request and kicking off your CI/CD pipeline. Now, this particular example is using GitHub Actions, which is the CI/CD capability inside of GitHub. And what we should be doing is rerunning the pre-commit hooks, rerunning some of those code analysis tools, rerunning our unit tests, rerunning any sort of OPA policies, the Open Policy Agent engine against all of those policies, maybe running some conf test policies, for example, to make sure everything's clean. We should have a nice, clean set of data that will tell you we're ready to actually move on to deploying this thing. The beautiful part of the GitHub Actions, which can go in and run all of these tools for you, is that it generates evidence. Those evidence files or reports can be archived and attached to the actual action build. And you can also display them right there on the dashboard. So this particular example is showing you, here's what some unit tests could look like. How many are passing versus how many are failing. And you've got all of that data right there inside of your CI/CD pipeline telling you how we're doing against our security policies. Inside of those GitHub Actions, you also can do some more advanced scanning if you need to. Now, this is inside of GitHub's advanced security package. So these can cost some dollars on your GitHub Enterprise license, but there's other options out there. You can use traditional vendors for SAST and DAST. You can, go pick up another secret scanning engine if you don't like GitHub's, for example. But conceptually, this is where you should be scanning for secrets, maybe on pre-push or a pre-merge to the main branch. We should be detecting secrets that maybe shouldn't be entering that environment. So you're seeing that with the secret scanning alerts in the screenshot. It's saying, hey, Eric, you've got, it looks like 23 secrets inside of this repo. Code scanning alerts. So if you're using GitHub Advanced Security, that could be CodeQL, which is the GitHub native engine for scanning source code. You can scan Java, you can scan C#, you can scan Python, Ruby, and a lot of the languages that are out there. And those are going to show up right here in the code scanning alert section, as well as on the pull request. So as you go to pull request, some feature into develop, you're going to see here's all of the different code analysis alerts on what's changed, and you can go correct those before you move forward in the workflow. Supply chain scanning is a huge topic at this point in time. Dependabot is the tool that's built inside of GitHub that actually does analysis for your package.json files, for your CS proj files in C#, your POM XML files in Java, and so on and so forth. and it will give you alerts. If it detects a vulnerability in a package, you will see it show up here, as well as you'll get a pull request that says you need to bump the version on Spring Boot from 2.x to 2.y, and you can just hit approve and make sure that that is still functional once it hits the dev environment to auto upgrade and go in and patch that particular vulnerability. So the code analysis or advanced security packages within these version control systems, in my opinion, is the future of dev-oriented security. It's all integrated inside of the ecosystem, making it very simple to review the results and make changes when you find something bad. Furthering our supply chain analysis discussion. So we mentioned Dependabot, which is scanning software packages referenced by applications and services or products, if you want to look at them that way. As you look a little bit deeper into the ecosystem, a couple other things to be aware of is that your containers, for example, are going to have a number of libraries in it that are not being scanned by Dependabot. So you're going to need to bring in some sort of container scanning engine to actually go in and scan the containers for you. We use a tool called Trivy, which is from Aqua Security. It has a GitHub action where you can just say, scan my image. And what that's going to do is pick up a bunch of the OS level libraries that are inside of a container image. It'll scan those for CVEs as well. As you're building your images and you've certified them with Trivy and with Dependabot, and you know that the scan's coming up clean, there is another open source security foundation project called Project SigStore that you really also need to be aware of as well. SigStore has a number of different repos and tools that it uses to improve supply chain security. As you look through those tools, you've got a project called Cosign, which is specifically designed to help you sign artifacts. So think of a container image or a binary or a Helm chart that's being installed inside of a Kubernetes cluster. You can sign those artifacts and you can store that signature in a location where you can then validate the signature before you launch the artifact. So it's giving you artifact signing. Supporting that ecosystem, there's a couple other projects called Fulkio, and then Recore is another one. And what those provide you is a code signing certificate authority. So think of Let's Encrypt, except for code signing certificates. And then Recore is the transparency log for all of that certificate usage. And what you can do is start using, it supports single sign-on through OpenID Connect and federated identity. You can even start using that ecosystem to sign all of your Git commits. You can also create a software bill of materials or an SBOM using a tool like Sift, which is from Encore. And you can create an SBOM for your project or your container image, and then you can sign the SBOM. So you're actually attesting, here is what our software bill of materials looks like. Anybody can take a peek at that and know exactly which packages they are inheriting and running in their environment before they actually go run that on their production server. So these are all tools that kind of complete the entire supply chain analysis security discussion, and that's all provided through Project SigStore. Very cool project. Go check that one out. It's really simple to get up and running, especially inside of the big three cloud providers. So as we're at the 2/3 point of the discussion here, everything I just walked you through to the end of that discussion went from very left in VS Code through pre-commits, through merge requests or pull requests, to a dev or a main branch, to building an artifact, and then to actually sign that artifact with something like Cosign. So all of these things get you to the point where you're ready to actually launch the ecosystem. Okay, so let's moving to shift right. What does the operational path look like to help keep up with the dev path that I just walked you through? Because if the dev team is moving that quickly and the operational team is still a bottleneck, this isn't going to work, right? The ops team has to be able to actually move at the same speed. So again, build the paved road. Instead of maybe the Node.js template, we need to be looking at automating our infrastructure for the apps to run on. That is very easy to do now using tools like Terraform or CloudFormation or Bicep, depending on which cloud you're in. So build reusable cloud infrastructure modules or templates that can be used to quickly spin up a set of resources in a GCP project, for example. Then start building some shareable gold images. We'll talk about some tools to build hardened gold images for VMs and for containers. And then you can start launching your APIs or your functions into the environment and know that they're running on top of a secured infrastructure. So let's start at the bottom up. We build up our cloud infrastructure. What do we need to be thinking about as we do that? Number one is finding somebody that can write your cloud as code. You do not want to build your cloud based on someone signing into the web UI and doing click, 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 click through a wizard in order to build out a virtual network or, spin up an EC2 instance, something like that. That's not repeatable. That is not a reusable module that can be scaled out across 1,000 different dev teams. We need to be thinking about, can we write these in Terraform or CloudFormation or Bicep and get them checked into version control? Because if you can do that, you can leverage everything I described to you in the shift left section against your cloud infrastructure. So we can set up those code editors. We can run tools like checkoff against them. You can set up pre-commit hooks. You can do secret scans, and you can identify cloud misconfigurations very early in the cloud infrastructure lifecycle and pick off a bunch of misconfigurations before they hit your cloud environment. On the shift right side of this conversation, we can also set up some actual security policies that need to govern the cloud itself. So pretend in this scenario, I have written maybe a Terraform resource. So it's an Azure storage account. And that Azure storage account is set up to allow public blob access. So basically puts blob objects on the internet. That's a no-no. So even though I wrote the template, even though checkoff told me it was a problem, and even though maybe somebody approved the pull request, we can set up guardrails in Azure using Azure policy that says there will never be allowed an Azure storage account with a public blob access setting. And Azure policy will block that creation of that non-compliant resource right there at the API level. So you set up your policy as code inside of the clouds. Terraform can even deploy and configure those policies for you. There's also another tool called Your from Bridgecrew, which is, think of this as the feedback tool. So it's the feedback loop from here's an EC2 instance to the actual Terraform code that defined it inside of my version control system. What Your does is it runs in CI/CD and it actually puts the git commit hash in some of the tagging information that lives on the real live running resource. So at any moment in time, your ops teams can go look at that EC2 instance and they can see, oh, there's the git commit hash for the last time this resource changed. And then they can go into version control, look at the history and say, oh, Eric is the one that made the update to that resource on that commit hash. We should go talk to Eric about what's going on with this thing because this configuration doesn't look right. So it's really just attribution. It's almost a git blame, but it lives in tags on the actual real live running thing. It's a pretty cool project. Cloud infrastructure, we've got that burned into code. Then we talk about configuration management as code. So this is building an actual virtual machine or a gold Docker image that you can share out across the organization. Back in the day of traditional enterprise IT, we would request a new virtual machine, maybe for running a bunch of scans or something like that. And it would take months to actually get that VM created. In the world of the cloud, you can have an Amazon machine image or an Azure VM image or a GCP VM image sitting there in a dedicated project or account or subscription, and it's just shared out with the whole organization. And you can update those by running your own config management driven pipeline. So configuration management as code is using things like Ansible, Salt, Chef, or Puppet to actually declare how we're going to configure the operating system. So think of a generic Ubuntu or Red Hat Enterprise Linux server. So you're going to stand up a vanilla RHEL box. Packer will spin that up as a cloud virtual machine for you. And then it will take your Ansible code and apply that completely custom configuration to it. So you're left with a VM that is what your gold image will look like when you started that thing up. Then you can use a tool like Inspect to actually certify or validate that all of your policies are met. So Inspect is a complement to the Open Policy Agent or OPA project. But instead of writing policies for cloud native configurations, you're writing policies against an actual operating system. So think of a policy that says if SSH is running on this gold image, it should be using SSH best practices. So it'll check the Cypher suites for you with a custom policy. Maybe you're checking the protocol version is set to 2 and things like that. And Inspect will tell you all of your policies are passing on this release candidate gold image. If it passes, then Packer will produce the actual snapshot for you and store that in the cloud account so you can share it with the rest of the organization. So that turns your VMs almost into a cattle versus pets mentality, where instead of the VM running for 5 years, we're going to spin up a new one based on the new gold image, relaunch the systems onto it, and we'll blow away the old vulnerable VM as patches need to be rolled out. It makes you very agile from a config management perspective. Continuing to build off of our automation here. Now that we've got cloud infrastructure and VMs and containers that are actually ready to run, how can we run some dynamic scanning against them? If you're worried about threat hunting or configuration drift on your gold images, OS query is a perfect way to write custom queries against that gold image when it comes to life. You can interrogate through SQL queries the entire operating system, every file that's on there, every configuration that's inside of that file, all the processes that are running, the ports that are open. It can basically be your version of Tripwire, if you want it to be, where you can, from a command line driven fashion, run a bunch of queries to make sure that that VM is okay. You've got automated network scanning. Now, FlanScan is open source, so I mentioned that on this slide, but that could be any of your traditional network vulnerability scanners. And you can start running that and feeding data back into the ecosystem. At the application layer, Zap has a Docker image that you can run inside of your cloud networks, and you can get more traditional dynamic application security testing for your APIs or your web apps to find application level vulnerabilities. And again, you can parse those and feed them back into the overall feedback loop. So think of dashboarding and aggregating all of this data. Taking that to the next level, you now need to turn on cloud compliance services. So using the same mentality, let's continuously evaluate all of our cloud resources. Let's make sure that everything is compliant out in the cloud, which is being defined by that Terraform code that we already talked about deploying. So this is kind of oversight and cloud governance. So cloud security posture management services, CSPMs, provide you visibility. You can use something native like AWS Security Hub to do this, or Microsoft Defender for Cloud, or you can move into more of a managed platform like Orca or Wiz or even Cloud Query, which is kind of like OS query, except you're using SQL statements to query all of the resources in your cloud. So you now have all of that data and you start figuring out how to feed that into custom policies as well as dashboards. One final stop on the shift right concept is assume that Security Hub or Defender for Cloud has notified you of a cloud resource that's violating policy. As you get more advanced here, you can start to take action against those things. So in this example, I'm showing you one way you could do this using Cloud Custodian, which is an open source tool from Capital One, but that could easily be setting up or being run by maybe an AWS Security Hub runbook or by an Azure Defender logic app that can go in and identify this volume that has been created without an encryption key. It can alert you, put it on the dashboard, but better yet, we can even go in and auto delete the non-compliant resource and then close the ticket out as part of the entire kind of incident response program to the cloud security side. So these capabilities are provided by Custodian as well as just serverless functions, giving you the ability to get constant feedback and also close tickets. A super powerful concept and one that we play with and do some labs on in 540 as well. That's a very beloved lab exercise by most of the students that take that. It's really fun to see these things just poof, go away when you create something insecure. With all the data floating around, the other concept that I'll leave you with kind of on a parting note here is aggregating all of the data from all of the different data sources that we've walked through over the last hour. I know it's gone by quick, right? So you will need to pick a vulnerability hub or some sort of centralized system for storing all this information. And as you grow and in your organization, and we've worked with a number of folks where we've collected details from code repositories out in Azure DevOps or GitHub or GitLab, run a bunch of our orchestration against it, fed that data into some sort of a storage bucket, and then run some custom Python code to kind of normalize and aggregate that data, and then push it off into some sort of a SIM-based system. So that's taking all your code and feeding the data into that particular system, but then you're also starting to aggregate data from Defender for Cloud, for Security Hub, Custodian data is being written in there, your Zap alerts, etc., are all hitting your central SIM, which gives you the dashboarding and querying intelligence you're going to need to send out notifications, open tickets, and maybe kick off that auto-remediated runbook for fixing some of the problems that you detect. That's your end-to-end shift right mentality. If you get to the point where you've got this working, you are doing a great job getting all of your intelligence into one location. So one conclusion slide remains here as we wrap up the session. Remember that security and governance culture is going to change as you move through into that DevSecOps accelerate mindset. One of the biggest pieces that I try to instill into security teams when I work with them on these topics is that treat that CI/CD pipeline as your friend. That's your compliance and control framework, as well as your ability to close vulnerability windows as quickly as possible. Use continuous improvement throughout the ecosystem. Learn from the other dev and the other ops teams and the tools that they're working with. And then based on that information, focus on rapidly changing and upgrading your workflows. Every week, there's some new tool or some tweak to a scan setting that you can use to improve the security and governance of the overall ecosystem. With that, we are at the top of the hour, my friends. Thank you very much for attending. If you've got questions about the presentation, I think maybe, Laura, we've got time for one or two potentially before we call it.
Perfect. We've got one waiting for you. Do you need a CA code signing certificate, or can you self-sign? Is self-signing your code considered a bad practice now?
I'm assuming this is related to cosign. The problem with self-signing is that it's impossible for your partners, not impossible, but it's not a validated CA for your partners to validate that your code has not been tampered with. So the idea with cosign is they provide the CA for you and you just generate certificates based off of that. And that gives the central authority for validating signatures. If you're distributing this amongst a bunch of companies, or if I'm an open source developer, I'm using a trusted third party, which is the SigStore project, to actually create and validate the certificates. So that's the big win there. Honestly, the project is trying to get away from using kind of like GPG keys. It's making it much easier, and it's got single sign-on, using your GitHub ID or any compatible OpenID Connect provider to generate those certificates. So it's a very smooth journey based on my experience thus far.
Wonderful. Well, that is the only question. So it looks like we're right on time to wrap up. Eric, thank you so much for the presentation. And thank you, audience, for listening in. And we look forward to having you join us again. Have a wonderful day.